Hello everyone, good to see you. People on the internet know me as Linui, and I have been at the Recurse Center this year to look at stuff that seemed scary and mysterious to me, like deep learning, for example, or assembly language, right? And another thing I wanted to look at was building my own compiler. And after that, I kind of was stuck for a few days thinking about which language actually to build a compiler for. But then I was thinking back of this class of programming languages called esoteric programming languages, which are not really meant to be used productively, but rather as to make a point, or as art, right? Or as a challenge, either for the designer or the user, and it could also be a joke. And maybe you have seen one of them, which is called brainfuck. And this is a language which only uses these 8 different characters to basically manipulate data on an entire tape. And it is Turing complete, so it can do everything other high-level languages can do, which is pretty amazing. Another example would be a language called Shakespeare, where the characters are variables, and when they talk to each other, they assign values to each other, which is super fun. Melbourne was designed to be as hard to use as possible, so it employs encryption and self-modification. And actually, after it was being published, it took 3 years for the first non-trivial program to be written. It's this one, and if you run it, you will get the output, hello world, with some uppercase characters. Defunct is a 2-dimensional language. Intercal has a politeness requirement, very weird operators, and comes from statement. And then there's folders. Programs in folders are basically nested empty folder structures. And this is Hello World, and a folders dialect called concise folders. There's also a very pure folders where the names are this is again Hello World. And I thought this was really funny. The point of this language is that if you look at the size of the structure on Windows and the file manager, it will say 0 bytes. It's hilarious. I really, really like this. And I kind of wanted to make something like that, where you use a structure that is not really meant to be used for programming, just to do that. So I was thinking of Git. If you look at the graph formed by Git commits in the Linux kernel, for example, you will get this large, complicated network of nodes, right? And I was thinking maybe you could use that to model a control flow for a language. That's what I did. At the core of the language, most esoteric languages employ either a stack or some endless tape, like brainfuck, for example. But I was thinking, why don't we have both? Yay! So you have a small set of instructions that you can put in the commit messages to tell the program what to do. Here are most of them that deal with the stack and the tape. And for example, if you have these instruction sets, it will put the number 42 on the stack. It will duplicate it and then add the 2 numbers together and output the result as an ASCII character, basically. Or here's another example where you put all the ASCII characters of the string on the stack and output the 3 characters one by one. But because we put the H at the bottom of the stack, we get the wrong ordering, right? So to fix that, we need a longer set of instructions, which basically takes all the characters, writes them on the tape, going from left to right, and then goes from right to left over it again to output it in the query. Only the first line of the commit message matters, so you can use the body of the commit message for comments, which is sometimes very helpful if you have sequences like that. Okay, and for control flow, in this language, the execution starts at the commit pointed to by the master branch, and then executes the instructions in that commit, and then looks at the parents of the commit. If there is only a single parent, we go to that one and repeat. And if there are multiple parents, which happens if you do a merge, for example, we look at the top stack element. If it's a 0, we go to the first parent. If it's a 1, we go to the second parent, and so on. That's how you do if-else statements, basically, in this language. There's a special instruction with these square brackets, and that just jumps to the git tag in the repository you have. That's how we do loops, basically. And yeah, which just exits the program. Okay, let's look at Hello World. We put our string on the stack. Then we have 2 loops. One of the loops writes the characters on the tape, as I explained, to like get the correct ordering in the end. And the second loop goes over in the other direction and outputs the characters, and then we quit. That's how this language. I was thinking about how to call this language, and a batchmate of mine, Janine, came up with a really good suggestion. So now it's called Legit. And Legit is really fun. It's fun because you have to write the programs backwards, actually, right? Because the first commit you make will be executed last. So you have to reverse it when typing. It is educational because you have to learn these obscure command line switches like commit, allow empty, or merge, allow unrelated histories, which I've never seen before, really. It's building character because if you make a typo somewhere, you have to redo all the commits that come on top because their hashes will change. And it's very mindful because you can't really track the program's history because it's already a Git repository, right? It's implemented as a small Ruby script, which you point to the directory containing your legit program, and it will output the thing in the LLVM intermediate representation, which is the thing I originally wanted to learn, right? Which is this weird assembly-like language with lots of type annotations. And this you can then like process further with tools like Clang, for example, to make a binary out of it, which is really efficient. So if you run this in the end, this binary, you will get like similar efficiency like in Rust or in C languages, which is fun. Let's look at the larger program which I made. It's a brainfuck interpreter. So it takes the source code of a brainfuck program and executes it. You ready? It goes over 6 pages or something. So first we look at all the characters and assign numbers to the different instructions, basically. So it will be a number, we will replace each character by a number from 1 to 8, basically. We do some setup, and then we have my favorite commit I ever made at the very top, which is it's a 9-way merge, right? We merge 9 branches together at the same time. This is the place where we decide, depending on the number, what we should do. And then the rest of the instructions are you telling the interpreter what to do for each instruction. And then either we loop back to the beginning if there are still characters left, or we quit. Right, and if you compile this, and then like pipe the hello world brainfuck program I showed in the beginning into it, we get actually hello world again, which is good. And then, just as I thought I would be done with this project, maybe, Kedor sat next to me and said, "Hey, could we write a crime in this language?" Which is quits its own source code, right? Here's a Python program that is identical to its, like the output is identical to its own source code, which is a really fun challenge. But for this language, I was not ready up for it. So I kind of left that as an exercise for the reader when I made a right, some aftermath. The by far most common reaction I got to this project was something like, "Oh, thanks for making this. I hate it." Which is fair, I guess. And also people were wondering about how to pronounce the name of the language. If it was legit or legit, before agreeing that it's probably pronounced like the replicator shape form. I got a pull request to one of my programs, to the Hello World program, because a friend of mine was of the opinion that it was missing an exclamation mark in the string. So what he did was adding 2 commits on top of my program, basically. The first one just pushes this 0, which makes the program like follow the first parent, and basically using his version of the string and skipping mine. I definitely accepted this pull request. And this was a person pointing out that my string parsing had a bug. It couldn't handle escape defaults correctly. And the person provided an improved version and said, I tested this with example programs and a crime I've been working on. And actually, I needed to like message him to ask about this, and he pointed me to this program, which was really a crime in legit, which is amazing. When you run it, it outputs the Git commands required to recreate itself, which totally blew my mind. It made me very happy that I put this thing on the internet. I'm happy that this exists as well now. That's all I got. Thank you.